This video is going to introduce you into random variable distributions. Specifically, we're going to talk about discrete random variables. So a student may take a 10-question true-false quiz. If they just guess randomly at each one, we could try to figure out the probability that they get 70 or more correct, or 7, 8, 9, or 10 questions correct. If there's a small company and they want to know the number of long distance phone calls their employees make during the peak of the day, then we might want to know what is the probability they make more than 20. So 21, 22, 23. All of those are countable. So we call them discrete random variables. It is still not sure which outcome is going to happen. There's still a probability tied to each one. So it's still a random variable, but because we can count the outcomes, it is what we call a discrete random variable. Now, in this case, we're going to let capital X, capital Y, capital letters denote the random variable, and then the lowercase letter corresponds to the actual values of that number. So if X is the number of heads you get when you toss 3 fair coins, then here is the sample space of all those tosses, and we'd say that little x then could be 0, 1, 2, or 3. Again, big X is in words, little x is in numbers. Probability distributions are going to have 2 characteristics. So each probability is going to be between 0 and 1, and the sum of all the probabilities of that function or that distribution is going to be 1. So let's suppose that Nancy has 3 classes 3 days a week. She attends classes 3 days a week, 80% of the time, 2 days 15, 1 day 4, and no days 1%. Suppose 1 week is just selected at random. So I would say that X is defined as the number of days attended class that week, where then little x is going to be equal to 0, 1, 2, or 3. So then the probability distribution we can put in a table like this with those outcomes. And then we can just use this situation to fill in the times. So 0 days, remember this is the number of days attended, so that's going to be 1%. 1 day attended is going to be 4%. 2 days attended, 15%. And all 3 days, 80% of the time. Notice that if I would have defined maybe Y as the number of days missed, I could still have little y be 0, equal to number of days missed. Now my table, my probability distribution, would just be opposite because this is number of days missed. So that's why it's important for you to know what your variable is. So 0 in this case means no days missed, 1 day missed, 2 days missed, and then 3 days missed. So it's important to define your variable and then know what the values could be. They should be countable because this is a discrete random variable.